Hi mathematicians, so today we are going to be learning a strategy called block method for multiplying double-digit numbers. Double-digit multiplication can look confusing at first, but when we break it down and apart by place value, we are going to model these building blocks using blocks that you guys I'm sure have seen, using blocks like these. This strategy is important because it helps us understand why multiplication works the way it does, not just how to get the answer. By using tens and ones and multiplying them together, we can learn where the standard algorithm comes from. So you guys have already used block to show tens and ones when we practice addition and subtraction. You've also built arrays to use multiplication facts. But today we are going to combine these ideas and show how the tens and ones can multiply together. You guys might confuse 10 blocks with hundreds or ones, or might forget to multiply each part of the number. But don't worry, I'll be labeling and clarifying as we count together. We'll be using partial products before combining them together as one whole number. Okay, mathematicians. So the question we're going to be working on today is going to be 15 times 23. So here I'm going to be building, and on this side I'm going to be writing out the question for you guys so it's easier to see, and then we're going to visually represent it. So we're going to be decomposing 15 times 23. So we can decompose these numbers by breaking up the tens and the ones. So 15 can be broken up into 10 plus 5, which we know equals 15, and 23 can be broken up into 20 plus 3, which we know equals 23. Okay, so I'm going to be representing these using our hundredths, which will be this blue flat, and our tens, or our longs, which will be orange, and I'll also be using our unit cubes, which will be yellow. All right, so first we're gonna put 10 and 5 across the top. So if we broke up, as we said, 10 and 5 equals 15, so we're gonna use one long, which would be 10, and put that first to represent our 10 and our 15, and then we're going to take 5 units to represent our other ones. So we're going to go 1, 2, 3, 4, and 5. We're going to make sure we're really even, so we're going to have an organized picture. And then we're going to next look at our 23, which we already broke up into 20 and 3. So then we're going to be taking 2 longs to represent 20. 20. Move it up just a bit so I have some more room. And then 3. So we're going to take 3 of our yellow units. 3. All right, guys. So first we're going to break down the different numbers that we can multiply this by. So we know to get 15 times 23, we can break apart the numbers. So first we're going to multiply 10 times 20, which we can see right here. We'd be multiplying the 10 and the 20 from the numbers, and this would be equal to 200. So next we're going to break down our 10 and our 3, which would be 10 times 3 equals 30, as we know. And then we're going to be breaking up our 5 and our 20. So 5 times 20, which we also know equals 100. And lastly, we're going to be breaking up our 5 times 3, which we know equals 15. Okay, guys, so let's represent these. So we got 200 as our first. So how could we show 200? Well, we could use our flats, which equal each 100. So I'm going to place the 200 that we got. If you can see, if we're multiplying this way across, if you multiply 10 times, it would equal 100 flat. So next, we're going to be representing our 30 that we got, right? So we can take our 3 longs and represent those with our 3 longs, which would be 30, which we got right here. So next we're going to represent our 5 times 20, which equals 100. So for visual purposes, I'm going to use our longs, even though we know that 100 could also be represented as 1 flat. But we're going to use 10 longs, which would also equal 100, as we got. So let's show our 100. 1, 2, 3, 4, 5. We're going to represent it because it goes all the way down. We're multiplying it times 20. So right here's 20. 1, 2, 3, 4, one more, 5. So next we're going to be representing our 5 times 3, which is 15. So we have our 5 across right here and our 3 right here. So that equals 15. So I'm going to grab my 15 units, which can be represented through these, as we remember, our yellow pieces, our yellow units. So 1, 2, 3, 4, 5. That's for one section. Then we'll do 5 more. 1, 2, 3, 4, 5. Move it up a little bit. And then our 5 more we can grab. 1, 2, 3, 4, and 5. Let me organize it a little bit so it looks neat, nice and neat. So 3, 6, 9, 12, 15 we have. Okay guys, so now that we have our visual representation and we drew out how we broke down the 5 times 23 into our different decomposing by place value, now our job is to add up the partial products that we already got. So we're going to add 200 plus 30 plus 100 plus 15. And if we add these all up, 200 plus 30 is 230, plus another 100 would be 330, plus another 15 would be 345, which would be our final answer. And then to check our work, we can go back and look at our visual representation. So we have 100, 200, we know this is 300, 310, 320, 330, 335, 340, 345. So we can see through our visual representation and our partial products that we came to the answer of 345. Okay guys, so today we used building blocks to multiply double-digit numbers. We broke down each number into tens and ones and multiplied each part and added the partial products. This helped us to see why the standard algorithm works and how it connects to place value. Now it's your turn. You guys are going to build 16 times 12 using the same model that we just practiced. So you guys will have your own visual representation, and you're going to also write down these partial products. So first I'm going to ask you guys, how can we decompose 16 and 12? And the second question I'm going to ask you guys is, what are the partial products that we will get? And then the third question is, what will we do with these partial products? The fourth is, can you build a model the same way that we did to represent 16 times 12? I'll walk around to check and make sure that your guys' model matches my description and my equation. If you like, I can also help you guys in any other way that you guys need. Thanks, guys.